Hi everyone. In this video, we will see how to chat to documents using retrieval augmented generation. We will use this PDF and its research paper on quantum computing in finance. So we will use this our document to chat with. So let's get started. First, we understand what is retrieval augmented generation and why it's used for, and then we will code our web app. So before starting with retrieval augmented generation, let's understand why do we need it. So first thing is that large language models have cutoff date. Like for ChatGPT, its cutoff date is September 2021. So it's aware only of data which was publicly available in internet, and also which was also it's not aware of data which was published or created after that date. So consider this document. This PDF is recently published, and ChatGPT is not aware of it. So for these scenarios, this retrieval augmented generation is useful. Also, there are other limitations like when it gives answers, we are not sure from which source it's giving, and also we are not sure if it's hallucinating or not, it's giving a real answer or not. So for such cases, what we do is that we provide it some context, and based on that context we ask it to give us answer, and that's what in summary retrieval augmented generation is. You can further go through this documentation, and it's very good. Now let's before continuing with retrieval augmented generation, let's see what is content stuffing. So content stuffing is main component of retrieval augmented generation. So here what we do is that in our prompt, we fill our prompt with context and query, and then feed it to LLM and ask LLM to get data from our context. So this time we are aware from where our data is coming. It's coming from our context, and based on that, it gives us answer. So let's see one example. This is ChatGPT 3.5. And here I had created prompt. So in this prompt, for given context, answer the question. And if you don't know answer, just say I don't know, don't provide any other information. And this is my question, what is mango? And this is my context, some information from Wikipedia regarding mango. Now if I go and paste it, it's providing data only from my context provided. Now I can ask any information related to my context. Is it safe to eat mango? Now suppose if I ask something which is not part of this context, if I ask what is orange, it will simply say that context does not provide this information. So this is what context stuffing is. Now let's move on to retrieval augmented generation. So let's see what are steps involved in retrieval augmented generation. So here we need two main things, LLM and vector database. And first we take some big piece of information like this document or any source, consider it a book, and then we convert all data to vectors or embeddings using embedding model like ADA from OpenAI. And when embedding converts this text to vector form, it makes sure that data which is semantically related is placed closer in vector form. So consider a book which have information regarding mangoes and oranges. So in vector form, vectors which contain data regarding oranges will be closer together, and vector which contain data regarding mangoes will remain closer together. Now, second thing which we do is that we take query from user, and then we convert this query to vector form, vector form will look something like this. And then we do similarity search in vector database. So consider this is vector database, this part, and it contains information regarding dogs, cats, and suppose lion. So when we do vector search for dog, it will search for vectors which are closer to this vector, vector which was created for dog, and it will get relevant information regarding dog. And once we get that relevant information, we take that query which was originally regarding dog, and the data which we got from database, or we can call it context, and then we do context stuffing. We combine context which we got from vector database and query. And one more thing to note is that from database we will receive data in form of vectors, so we convert back that vector to text form and then feed it to LLM. So if I show this diagram, so in this flowchart, whatever we saw earlier, we have search query, and then we convert our query to vector, and then in database we search for vector and get relevant context, and then we combine question for plus context and pass it to LLM model. And this is also same thing. So here if we see in Pinecone vector database, we can store data regarding cat, gardening, and cooking. So this will be the first step. And in second step, we will take the query, convert it to vector, and then we will perform similarity search from vector database. And then we will, whatever data we will receive, we will convert it back to normal text sentence, and then we will pass that context and query and our prompt to LLM model and get the data. So one more thing is while storing the first step, when we store data in our vector database, we take data from some source, and then we transform that data in small chunks or small subdocuments, and then we create embedding and store that data. So now when we know what is retrieval augmented generation, let's get started with coding part. So let's first of all create ingest.py file, and this file we will use for this part. We will take our data source, we will load data source, and then we will use embedding model to store that data to our database. And before we start, for this tutorial, we need OpenAI API key and Pinecone region and Pinecone API key. Also, in dependencies, these are dependencies installed. Some of these we might use, some we might not use, but if you get error regarding something, make sure to install them. Also, I had downloaded and copied that PDF and renamed it as qfin.pdf. We will use it. So let's open ingest.py, and first of all import OS, and then import .env. So from .env I will import load.env, and then load.env. Then from LangChain document loaders import PyPDF loader, and we need text splitter to split our data in chunks. For that I will import text splitter, recursive character splitter. So from LangChain.text splitter, import recursive character text splitter. These are part of this retrieval module, and document loader we have document transformer, and text splitters are part of transformers. Then we will import from LangChain vector stores. We need Pinecone. Also, let's import Pinecone. Important thing here is that the Pinecone which we import from LangChain is it has P as capital case, and this Pinecone client which we import have everything is small case. Also, let's do Pinecone dot init, and it will take two things. If I hover over it, it takes environment name and API key. So let's do it. API key equals to os dot environment dot get, and it should be Pinecone API key. So I will copy paste, and the second thing which it needs is region. So that will be environment. Same thing, os dot environment dot get, and here we need this Pinecone region. Now let's load the document. So I will create current dir equals os dot path dot dir name, and then directory of this file, and let's print this current dir. Yeah, it's good. Now let's create variable for path of our file. So that will be os dot path dot join, and in current dir we have qfin dot pdf. Now let's load the file. So I will create loader equals to PyPDF loader. Make sure that PyPDF is installed, and path file path equals file path. Now let's do data equals loader dot load, and now it will load all data from PDF. Now let's create chunks out of it. So I will create text splitter equals recursive character text splitter, and here we need to pass chunk size equals, let's give 100 only, and chunk overlap, the overlap between chunks which we want, let's keep it 20, and by default it will take separator as next line characters, so I will leave it. And now let's create chunks, and chunks will be document, not document, text splitter dot split document, and here I will pass the data which we had loaded, and let's print out our chunks. Also, let's print out length of chunk. Okay. So we have 2752 chunks. Now If I go back to that retrievals, now we loaded the data, we transformed the data to chunks. Now we need embedding model to create embeddings out of these chunks. And for embedding model, we will use OpenAI ADA. So if I see here, we use text transformers, and this is the embedding model. So we will use OpenAI embeddings. Let's import it from LangChain dot embeddings, import OpenAI embeddings, and also create one embedding equals OpenAI embedding. Since we are already exporting that key, OpenAI API kit will take that key and we do not need to pass it. Now we can pass in embedding, we can pass our text, and if I go here, by default it's taking model as ADA. Let's pass model also. Right now by default it's ADA. I will still pass ADA. And now let's use this embedding model to store our data in Pinecone vector DB. So if I go to this step in retrievals, now we have our embedding instance created. Now let's store data to Pinecone database. And if you don't know what Pinecone database is, there is separate video on embeddings, vectors, and Pinecone database. You can check that out. For quick summary, Pinecone database is database which is used to store vectors, and it's also useful for doing search operation over vector, like similarity search. So I will go to Pinecone and create index. I will give it name as chat PDF, and in dimension I will pass 1536, and 1536 we are passing this because that's what the dimension of embeddings which is created by OpenAI ADA 002, and metric I will keep default, and then just create index. Yeah, it's initializing now. Now we can go to here and we can do Pinecone dot from documents, and this thing accepts documents and embeddings. I go here. It should also ask for text embeddings. Okay, so it should ask index name. Index name we created demo or chat PDF. So index name is chat PDF, and then we need to pass embedding, which is embedding itself, and then documents. So in our case, documents is chunks. Now when I run this file, it will create chunks, and then it will just convert all our chunks to vectors and store them in VectorDB. But before that, let's estimate the cost of this operation. So in last video, we saw how to do it. I will just copy the function from last video and paste it here. So this is embedding cost calculator. I will comment out this line for now, which will store data, and I will print embedding cost calculator, and we'll pass our chunks there. Chunks equals chunks, and run it. So it will give us approximate cost of this operation. So it's this much, $0.018. Okay. Now it's not required anymore. We can go ahead and run this file, and it will store our vectors. It will take some time. If I go to Pinecone and come back here, then once it starts pushing vectors, we should be able to see this updating. Yeah, it's updating now. Now upload of all vectors is done. Totally 2752 vectors are uploaded to Pinecone, and here now this Python file also stopped running. Now let's create another file and call it backend.py, and in this file we will move on to second part. So first part is done, this uploading of embedding to Pinecone. Now in second part we will take one query and then we will convert it to vector and perform similarity search and do this all flow. So for import part, let's import from here to here. Also we need Pinecone and .env, so let's import them. Now let's create vector store equals Pinecone dot. So last time we used from document, but this time we will use from existing index because we know that data is already there in index, and index name is chat PDF. So I will pass index name as chat PDF, and it also need embeddings. So I will quickly copy this part, embeddings, and paste it here. Embedding equals embedding. Now let's go back to documentation and retrievers. In retriever, vector store retriever. So this is for Chrome. Yeah. So once this is for not for Pinecone, but it's similar. So once we create, it's not. This is for Pine. This is for another FAISS. But similar thing we can also follow. So what we can do, we need to create a retriever, and we can do vector store dot as retriever, and in as retriever we can pass what type of search we want. Search type equals I want similarity search. So at the time of searching in Pinecone, I want it to do similarity search. And second thing is that I can also specify how many searches I want, like how many top matches I want. So let's specify that I want 3 matches, k equals 3. And in last video, when we were doing similarity search operation in Pinecone using Pinecone client, we saw that we pass k top argument, and same thing here we are passing as search k or sk equals k3. Now let's do similarity search first before doing retrieval or retrieval QA chain. So first let's do retriever response equals retriever dot get relevant documents, and in documents I will pass whatever the query I want. I will pass let's quantum mechanics. So what it will do, since we had specified similarity search, it will go to, if I go here, so it will convert our quantum mechanics to vector, and then in database it will match for all similar vectors. Let's print out result and see if it's working. Okay, so we got 3 results, this one, and this is page content. It's very small, but I think it's not showing complete page content here. And this is page. Okay, this looks like page number. Here it's not giving matching threshold or similarity score threshold. We can also specify threshold before if this minimum threshold, like if threshold, matching threshold is below this number, then it will not come in result. So let's add this also. So we want 3 results, and include those results only if matching threshold is more than 0.5. Now we got similar documents here. Now we can create our own LLM chain and pass context and everything we can do, or we can use RetrievalQA chain from LangChain, which will do all this for us. So I will import from LangChain dot chains, import RetrievalQA chain, and also now we need LLM model or chat model. So I will import from LangChain dot chat models, import chat OpenAI. Let's create chat model equals chat OpenAI, and model name I want GPT 3.5 turbo, and temperature let's keep 0.5. Also let's keep verbose as true. This is not required now because this was just to show how similarity search works. You can comment it out. Now we can do response equals retrieval QA chain dot from chain type, and it will take LLM. So we will pass our chat model, and then it takes chain type. So chain type equals, I guess by default it's stuff. If I go here, yeah, by default it's stuff, and we are also going to use stuff only. In documentation, you can go to chains, documents, and these are the types which we can specify. So this is stuff. In stuff, we simply stuff our context with our query to the prompt. It simply means that. Here we should have retrieval QA documentation also. Contextual. It might be here somewhere. Let's continue. So now we pass chat model and chain type. Now we also need to pass our retriever. And retriever we had already created that it will retrieve from this index, and this embedding it will use, and additionally we have passed this thing. So let's pass retriever as retriever and print it. So print response, not response. It should not be response. It's retrieval QA chain. So let's call chain simple chain, and now let's call response equal chain, and here it will accept query as dictionary. So query, and here I will pass. Let's see what is the objective of this research paper. And let's print out the response. So it will go to document, and we'll search. It got some error. Pinecone.similarity search got unexpected keyword argument score threshold. Okay, looks like Pinecone not supports, or even if it supports, something might be wrong. So for now, I'm removing score threshold and running it again. So what will happen is that this query will be converted to vector, and we will do similarity search in vector database, and whatever context we will return, that database will return, we will push that context with our query to LLM, and all that will be done by this retrieval QA chain. Let's add verbose equals, okay, it's printing 2 times for some reason. It says, what is the objective of research paper? The objective of research paper is to provide broad view of concepts and discuss a wide range of quantum finance topics. So it's able to chat with, or not exactly chat, it's able to receive information from the document. Let's ask some other question. What is this document have? Quantum blockchain. Let's run it and see why. Okay, it printed 2 times because here we have 2 response print. Till it's running, let's convert this to function. Since we added verbose s2, it's there, it's giving extra information this time. And this is the result for what is quantum blockchain. Now let's quickly create one function. So I will copy it, and def function name, let's call rec, and it will accept query, and I will paste everything here. So we have embedding, we have vector store, we have retriever, we have chat model, and chain. At the time of returning, we will return response. Also here, instead of hard coding this to query, we will pass as query. Now our function is ready to be used with Flask API. Let's go and create it. So I will do server.py and we will use this old code in fifth branch. It's simple LLM app. And here we created server.py file. I will just copy it and paste it here. So we are importing Flask, and from backend we will import rag, and then we are creating two routes, one for HTML web page and another for the chat route, where we will receive query from frontend and process it and return to user. Let's rename it to query, and we will pass this query to rag function, and whatever response we will receive, we will return back to user. So looks like API part is handled. If you are not sure how things are working, you can go back and watch that video. For now, let's go and create templates folder. So templates, and in templates we need home.html. For home.html, we are in templates, we have home.html. I am just using modified version of this, so I had already copied it. And in this home.html, we are just taking input, and we have one button here. We are taking input and we have one button, and on click of that button, we are calling this function. This function will read input and then do the API call to chat route which we have just created, and it will pass input as encoded URI component to that route, which we are reading here as request arguments. And once we receive the response, we will just do normal DOM manipulation to add results in the DOM. Let's save it. And now let's just run it. So it started server at port this number. We can go here. It's already open. I will open network tab. And let's ask, what is, same question I will try, objective of this paper. So when I do ask, then this API call goes with this as URL, this query as part of URL, and here I got the response. So it should have come at the bottom, but okay. Now let's ask another question. What is quantum mechanics? If I go here we can see that as soon as we pinged it from frontend, we started RetrievalQA chain here, and it finished the chain and returned the response in frontend. I got here. So this was the first question, and this is second question. What's quantum mechanics? Now let's ask, what is clock? So what's limitation here is that we are not maintaining any history, and because of that, suppose I ask question that what is quantum blockchain, and then if I ask what is its use. Now thing is that it will not know. I'm asking what is its use. It will not know for which thing, for whose use I am talking about. So if I do this, then it will give me some random data from the document. See? So what is use? So it's just giving the function is used to protect sensitive data from the information. Okay. Looks like CSS is not working properly. It's saying that use of function is to protect sensitive data. But if I go here and quantum algorithms, blockchain. So here, definitely we have more information available regarding quantum blockchain. Blockchain. Yeah, quantum blockchain, and here we have advantages of quantum blockchain. Okay, so I will modify my question. What are its advantages? Let's see. So here is saying advantages as innovation, problem solving, but these are advantages. These are advantages which it's not able to find. The reason is that it's not able to find what it's refer here. It's not able to find that it's refers to quantum blockchain, and for that we need to maintain history, and to maintain history we need to use conversation chain instead of retrieval QA chain. So if I go here, we need to use conversation chain, which we will see in next video how to do it. It's basically same code, just with minor modification in this wrap function. We will do that in next part. To summarize, whatever we done in this part is that first we created index.py and ingested all our data, converted all our data to embeddings and stored in Pinecone database. Then we created this backend file, and here we performed similarity search and passed that data as context to LLM model. And then finally we created these two routes with front end to show data. Whatever we are doing in these functions, we can see those things in browser. So this is it for this video. Thanks for watching.